Hi, and welcome to my presentation on artificial intelligence in structural engineering. My name is Vorster, and I am currently director at BuildBIM, as well as a director at my own company, BIMworks Limited, based here in New Zealand. I have got more than 20 years experience in the AEC industry, working as a fabrication detailer, BIM manager, digital engineer, and also a software developer. My information is here on the screen, so please feel free to connect with me. I'm always happy to share content and information on an international level. So if you find this useful, the stuff I'm going to show you today, and you want to have a downstream discussion about this, feel free to reach out to me and we can have a chat anytime. Also, if you're interested in using the software and the examples that I'm going to be demonstrating here for you today, have a look at the link at the bottom, bimworksfea.com. You can find the software GenFEA there, and that's the software we'll be using today to connect to Advanced Steel and to perform some structural analysis and seeing how we can utilize artificial intelligence to perform some structural engineering design calculations. Right, so let's jump straight into it. So first we'll just look at the general workflow overview. And the way this presentation is structured is we will cover some theory aspects and look at the workflows at a high level, and then we'll jump straight into the software and I will show you how it's done. And feel free to try this yourself. Again, I'm going to show you where to find all the example files so that you can practice this in your own time. So the workflow is we're going to be using Dynamo to export AutoCAD Advanced Steel models to a CSV format. We're then going to import those CSV files. There'll be two of them, one for nodes and one for frames, into the GenFEA software. Once in GenFEA, we'll be adding some analytical components such as supports and loads to the model. Then we're going to perform a structural analysis, and we're going to use the output of those analysis results to plug into DesignMate. This is the AI engineering assistant within GenFEA to perform some structural engineering design calculations. So very exciting. Right, the first step is looking at how we use Dynamo to export the AutoCAD Advanced Steel model to CSV. The workflow is make sure that you've already installed Dynamo for Advanced Steel. So you'll know this by going to the add-in ribbon tab in Advanced Steel, and you should see Dynamo for Advanced Steel there as you see on my screen. Then open up the analytical export ASCSV.dyn file. This is located in the GenFEA install folder in your My Documents folder, and I'll show you where that is on my screen quickly. So it's located here under Samples, under FEA, under BIMworks, and if you then navigate to Dynamo and then AS for Advanced Steel, you'll see the sample analytical export Dynamo script located there. There's a couple of important things we need to do in Dynamo. We need to specify the output path for the CSV files to export. Again, there's two of them, one for nodes and one for the frame elements. Once it's done, we need to select the elements to export and click on the Run button to perform the export procedure. So let's jump into Advanced Steel and see how that is done in action. Right, so we're here in Advanced Steel. You can see that we've got a portal frame structure model here. And if you're not familiar with Advanced Steel, it is not a CAD package. It is more of a BIM compliant package. In fact, it works with intelligent parametric elements such as steel elements and steel connections. In fact, all of the steel connections in the current version of Revit is a derivative of the Advanced Steel connections, and there's also a bi-directional link between Advanced Steel and Revit. So although we're using Advanced Steel in today's exercise, you could apply the same principles using Dynamo for Revit. So in Advanced Steel, we're going to go to the Add-ins ribbon tab. We're going to click on Dynamo for Advanced Steel, and we're going to open up that analytical export ASCSV file. This will take a second to open, and once it's open, there are three steps that we need to follow. So the first one is we want to head to the end of these nodes here. There's not too many of them. It's not a complex script. It's actually quite easy to set up, but you don't have to worry about that. It's already done for you. So all you need to do is head here to the file path where it says the one at the top that indicates the frame elements, and we're going to click on Browse. From here, we're gonna select the file path where to store the CSV information. Mine is already set to my Dynamo sample folder within the BIMWorks FEA examples, and I'll just leave it there. So I'm gonna select this frames file and I'm gonna click on open. If it doesn't exist, you can type in a new file name there and just click on open. And I'm gonna do the same for nodes. So the nodes will be stored in the nodes CSV. And the last step here is to select the elements to export. So I'll just make sure that I can see the advanced steel model here in my advanced steel model space. And then in Dynamo, I'm going to click on the first node here that says select advanced steel objects, and we click on the change button. Click once to activate your AutoCAD model space environment. Do a cross selection, select everything, and right click to accept the selection. Once that's done, click on the run button, and you'll know that everything has gone smoothly when you can see the geometry of the advanced steel model being represented in the Dynamo screen. Now that that's complete, you can go ahead and close your Dynamo, and for that matter also advanced steel. We are done with the step and we'll head on to the next step. Right, now that we've generated those CSV files, let's see how we bring them into GenFEA. The first step is to create a new project in GenFEA. We need to specify the project name and location. The location is important because this information will be used by DesignMate to determine the appropriate standards, design standards, and conditions to use based on the project information. We need to bring materials into GenFEA from our material database into the current project. The same with sections, so we're going to bring in 4 sections, one for columns, one for rafters, one for the bracing, and one for the purlins. We'll add some design groups, and this is also important because by organizing our structural elements into design groups, it's going to help DesignMate to interpret the information much better and design based on the elements belonging to a design group, and it'll become a bit clearer as we go down these workflows. And then we need to fix the imported content. So I'll explain what that means in a second. Once we finish with that, we're going to navigate to the nodes sheet, and we're going to bring in the CSV file into the nodes input workbook in GenFEA. We're not going to be performing any renumbering or optimization yet. We'll do that later because remember, the information at this stage between the CSV file for the nodes and the frames are connected. So if we renumber nodes, it means we'll lose that associativity if it's done before we bring in both the CSV file for frames and nodes. So then we're going to repeat the process for the frame elements. We're going to remap materials and sections. We're going to specify the missing values such as rotation and type. We're going to assign the design groups we've set up. We're going to assign them to the elements. And then we will discretize the model and do a cleanup of nodes, renumbering elements, fixing directions, and updating the model. Right. So let's jump into GenFEA and start the process. So we're going to create a new project. We'll specify a name here, and I'll just call this one Dynamo Example. I'm going to click on the button to select my location, and I'm based in New Zealand in Auckland, so it'll default to my general location. If you're located somewhere else in the world, then of course, the map will know that already. It doesn't know your exact address, so don't worry, but it does know your general area. So I'll just select any location there in Auckland, and I click on OK to set my project information. The next step was we wanted to head over to the materials input sheet, and you could do this here from the sheet tabs at the bottom or just selecting it here from the drop down at the top. And you activate these dynamic ribbons by selecting the component or the workspace that you're working in. So if I click on any cell on the sheet, the context ribbon for materials in this particular case will appear. If I click on the model, the ribbon changes again, and so on and so forth. So when I've got materials activated, I'm going to click on open, and I'm going to choose the S355 material to add to my project. I'm going to close that palette because we're done with materials, and I'm going to bring in the sections that I want to import. In this particular case, I want to bring in some universal columns. So I'm going to select this one here, the 200 UC 46.2. We're going to go back to our universal beams. I'm going to bring in this 200 UB 18.2. I'm going to bring in an equal angle here for the bracing, and it's going to be the 65 by 65 by 6 in my case. and we will bring in a cold form lip channel, and it can be anyone really. It's really up to you. I'll just choose this one and click on add. Now that that's done, again, I can close that palette. We don't need it anymore. I'm going to head over to the groups tab, and from here I'm going to click on add. I'm going to specify the name for this group, and this one is going to be columns, and we'll leave the color as blue and click on apply and new. I'm going to do the same for my rafters design group. We'll change this one to a different color. We'll make it cyan, and again apply and new. We'll create one for bracing elements, change this color to yellow, apply and new, and then we're going to do one finally for purlins, and we'll make this one magenta. All right, now I'm just going to click on apply because we're done adding our design groups. I'm heading over to the nodes sheet in my input workbook, and from here I'm going to click on import CSV. Once I've done that, I'll navigate to the location of those CSV files I exported, and here they are. The first one I'm going to bring in is the nodes sheet CSV because I'm in the nodes sheet. As I mentioned, don't do any cleaning, discretizing, or renumbering yet. We first have to bring in the frame elements. So I'm going to change to the frames elements input sheet. I'm going to click on add. Oh no, sorry, I'm not going to click on add. I'm going to, let's remove that one. I'm going to click on import CSV, and we want to bring in the frames CSV there. And there we go. Now there's a couple of things we need to do here to fix up the data. The first one is the materials. So all the materials has to match what we've got in our database, not what comes from Advanced Steel. So I've just selected the drop down here, selected the correct one, and now I'm going to click the first cell, scroll down with the mouse wheel, hold in shift, select all of that, and press Ctrl V to apply that to the rest of the elements. Now for the section mapping, we're going to do something different. I'm going to click on the filter here. I'm going to isolate all of the columns, these sections here, as they came from Advanced Steel. I'm going to make sure I scroll to the top. I'm going to click on the drop down and assign the column that we want to bring in. Control C to copy it to the clipboard. And now be very careful. Don't press Control V because we've got hidden lines or hidden rows in this sheet. So if you press Control V in this case, it's going to fill even those hidden rows. If we want to tell the software only to fill the visible cells, we click on the button here, Fill Range, and that will do the job for us that we desire. And then I'm going to do the same for these IPE sections. I'm going to make them all the same. Of course, you can be more detailed in your own practice sessions, but for now, we'll just keep them all as 200 UBs. I forgot here to add the design groups, so while I'm here, let's do that since we've already applied the filter to these. So I copy that again, use the fill range to paste it. Let's go back and also do the same for the columns because I forgot to do that for the columns. And it's very quick, so we just select there, click on fill range, and there we go. And now let's move on to the angles or the bracing components. These are rectangular hollow sections that was originally specified in Advanced Steel. We're going to make them equal angles. And the group here is going to be bracing, and we'll apply the same settings here. And finally, we are going to do the purlins. So we just repeat that step, and we select the cold form lip channel. I'm going to scroll down, hold in shift, and click on fill range. When we do the groups, I do the same thing. Click on the drop down, select purlins. I'm going to select these cells and click on fill range. Now I'm going to clear all my filters. So I can click on clear filters, or I can just choose select all here, just like you would in Excel. I'm going to specify a rotation angle of the cross sections as 0, and all of these elements are type beam. And now I am going to make sure that I paste those values into all these cells as you see on the screen. Once that is done, we are ready to parse the model information, not ready to analyze yet. There'll be several errors. We don't have any supports. We don't have any load cases or loads applied. And of course, let's first inspect the data as it comes through from Advanced Steel. The model order tab comes up and it's picking up some errors. We're just going to unpin that so it sits on the right hand hidden palette there. And let's look at the model. Now the first thing here is if we look at the framing elements, we'll notice that they are continuous. In other words, they're not discretized, they are continuous. And we would expect those elements to be split at the nodal intersections, and currently they're not. So to fix that, we're going to right click anywhere in the model space, and we're going to choose discretize elements. Once that's done, I'm going to right click and choose clean nodes. This is going to clear all duplicated nodes in the project. We'll choose renumber. I'm going to right click again. I'm going to choose fix the orientation. And finally, I'm going to choose update model again. You don't have to click update model. I just like to be thorough and make sure that everything checks out. So I just add that step at the end. But now you can see if I try to select the elements, they are highlighting and discretized across the model. And in fact, if we click on the show labels button here, it's going to help us to visually very quickly inspect and see all the blue labels indicate beams, the red labels indicate nodes, and I don't see any duplications or anything wrong in the model. So far it looks pretty good. Let's head over to the next step. So the next step is to add analytical components to the model. So to do this, we're going to navigate to the nodes sheet. Then we're going to use the select tool in GenFEA to select all of the supports located at the bottom or the base of the structure. We're going to go back, click on any cell in the nodes input sheet to display the contextual ribbon. We're going to choose edit, and we're going to switch all the boxes on for translation and rotation to indicate fixed supports. Then we're going to hit on apply. And once that's done, we'll add a load case. So we'll just add a single load case called LC1. And we're going to specify that that indicates the own weight of the structure. After that, we'll apply some loads to all of the purlins in the model, and then we should be ready to run analysis. So let's do that very quickly. I'm going to set my view to a front view. I'm going to use the box select here, select all my nodes. I'm going to head over to the nodes sheet here. I'm going to choose edit, and I'm going to select the boxes for translation and rotation. So you'll notice that it's added a Y value to indicate yes to all of these nodes located where Z is 0. Now I'm going to navigate to the load cases input sheet. I'm going to click on add a load case. I'm going to check the box that says contain self weight. Leave the rest of the information as per default. We'll do a linear static analysis for this one. So all we need to do is to click on apply. Then we're going to be adding loads. So a quick way to do this is bring your cursor on top of one of the purlin elements, right click and choose select all from group. When you do this, it's going to select all of the purlins, and from here we can go back to the load sheet, click anywhere in the sheet, click on the add drop down and choose line load. The default load case is LC1, it's the only one, it's already selected. So for the force and Z, we'll type in -0.3 and hit apply. Once that's done, we can choose to deselect everything in the model. Let's have a look at the next step, performing the structural analysis. This one is quite simple. We're just going to click on the Run All button and we will view the results. So click anywhere in the model space to navigate to the Model Ribbon tab. Click on Run All to run through the analysis. This should happen quite quickly since it's only linear static and a single load case. So once all of that is done, you should see the results output in the model. From here, you can switch on deflections. We can start playing around with the animation. We can view different forces in the beams and a whole lot more, like looking at support reactions. If we want to isolate only in the Z direction, for example, we can do that, etc., etc. I'll leave that for you to play around with. Now that we've got the analysis results, we can get to the fun bit, which is using DesignMate to start designing components. To do this, we're going to click on the DesignMate button from the workspace ribbon. We're going to select the DesignMate AI persona. We're going to select a design group, and then we're going to choose Prime LLM, and that's going to send information, critical model information, such as materials, location of the project, sections, extreme forces, etc., for that particular design group, to DesignMate, and it's going to study that information, and then we will follow up by asking it to perform some design calculations for us. So let's jump straight into that. We go to Workspace, we click on DesignMate. While that's loading, I'm going to just unpin my input workbook since we're done using that for now. I've already had this open, of course, so I'm going to start a new chat and I can see my AI persona there. By the way, if this is the first time you use GenFEA, you will have to go to models and enter your OpenAI API key there. If you don't, you can still use the tool for free, but it's going to default to the GPT 3.5 LLM, which is not nearly as powerful and accurate as the GPT-4 Turbo. So I recommend getting an OpenAI API key. It only costs $20 per month, so it's really cheap, and the usage is extremely low. It's less than a couple of cents, less than 10 cents for an entire design operation. From here, I'm going to select my columns design group and I'm going to click Prime LLM. And what this is going to do, as you can see on the screen, is it's priming the LLM with crucial information about the model. And we can see the response here from the GPT-driven design mate, that it is understanding the project information. Now we're going to click on the concrete design dropdown and we're going to choose rectangular isolated footing from design study. We need to enter some values here, the preferred footing depth. If you want to say to be determined or anything there, you can do so. Remember, it's AI, so you can add any natural language in here. It's really up to you. I'm specifying some default values or just some imaginary values here for my steel strength, concrete strength, soil bearing capacity, and whatever I want to leave blank, I can leave blank. Once it's done, you just click on the send button, which you can't see because it's behind my face here. But when you hit that button, it's going to send the instruction to DesignMate and it's going to start performing calculations based on your location. It'll select the appropriate design standards, as you can see here in my case, and you can see it's actually starting to calculate stuff here. While that's happening, you'll notice that there is a whole lot of different design templates here for concrete, steel, and timber. The ones that says design from study indicates that it's going to use the analysis results from the model and apply that into the design. If you didn't want to perform an analysis in the model and you just want to do a standalone design, you can do that by choosing the alternative option there. All of these templates are editable and you can add your own DesignMate templates. So if you wanted to create your own templates, you can go and specify them here. It's got a bit of a scripting language, but also a UI to help you set up your own design templates, and they will automatically pop up in DesignMate the next time you run DesignMate. So apart from the ones that ships with GenFEA, the ones that you see here, you can even create your own design templates. So really the possibilities are unlimited in terms of what you can do. And you'll see it's a pretty small footing that it's done here, and that's because we haven't got too much loading on our elements. And once this is finished, you can continue to interact with DesignMate, or if you want, you can start practicing and using some of the other design components here, like base plate design. If we want to do steel beam verification, we might want to change our design group to something like rafters and prime the LLM again. And you might actually want to start a new conversation when you change your design group, just not to have too much ambiguity within the same chat. But it's as simple as that, and I hope that you find it as interesting and exciting as I do to see AI in action, seeing it perform calculations and running through the process. Thank you so much for your time. It is a privilege to be able to speak to you, and if you scan this QR code, you'll be able to connect with me on LinkedIn. Feel free to reach out and continue the conversation. If you'd like to know more information about GenFEA, how to use it, where to find it, how to license it and all of that, reach out to me anytime. And I sincerely hope that you have a great day and that you found this very useful. Thanks and bye.